Hello everyone, I'm Arvo from Keystone. Today I would like to share with you some useful knowledge about frictions in physics. I think everyone is very familiar with the word frictions, and friction is presenting everywhere in our daily life. And for example, if you are running on playground, then there must be frictions between your shoes and the ground. If you see a car that is riding on the road, then there must be frictions generated between the car's wheel and the road. However, what is the rigorous definition of frictions in physics? Let me tell you the answer. The frictional force is considered as a contact force that exerted at a microscopic level by repulsive electrostatic forces between objects or fluids so close that atomic electrons repel one another. And frictional force is particularly when an object's surface is microscopically rough, caused by interlocking of the surface features of the two objects, always opposes the relative motion of the two objects. And since the frictional force is a force, so the system international unit of friction is Newton, abbreviated as capital N, and it is a derived unit that is equivalent to kilogram meter per square second. And the unit is named after famous 17th century English scientist Isaac Newton, which I think everyone know him, and who first incorporated the idea of force into a set of laws.
What decided the magnitude of frictions? First, we need to know that scientifically there are two types of friction. One is called static friction, where there is a tendency to resistance motion between two surfaces that are relatively static. Then it is the dynamic friction, when two surfaces move past each other. And the magnitude of frictional force is denoted by the function Ff equal to mu s times Fn for static frictions. And the Ff is frictional force, and the mu s is the coefficient of static friction between the two surfaces. And moreover, the Fn is the normal reaction force between the two objects. However, it is very important to know how to find the accurate Fn. The normal force must be the force that is perpendicular to the direction where the frictional force is generated. So in the paradigm, there is a mass placed on a table, and so the frictional force is horizontally, and the Fn must be the weight, which is the force of the gravity that is generated by the mass, so it is perpendicular to the frictional force. Moreover, for dynamic frictions, the magnitude of frictional force is denoted by the function Ff equal to mu d times Fn. And dynamic friction happened after the static frictions, where the motion force is larger than the static frictional force. So the object is moving and enduring the dynamic frictional force. And the mu d is very similar to mu s. It is the coefficient of dynamic frictions. In addition, it is a common sense that for any objects, the mu s is always larger than its mu d, which means the frictional force endured by the objects in static is always larger than dynamic. Since friction is the force, so we can use another way to find out the magnitude of frictional force and its coefficient, which is applying the law of conservation of energies. The energy of mechanical is equal to the sum of kinetic energy, potential energy, and elastic energies. And in the paradigm, there is a mass that is placed on the road, and it has an initial velocity 5 meters per second, and its mass is 10 kilogram. And we know that after 5 seconds, its final velocity becomes 0 meters per second. So we can applying the Silhouette equations. The distance is equal to u plus v divided by 2 times t. And by applying these equations, we know that the distance traveled by the object is about 12.5 meters. And now we can applying the conservation of energies. So the E total is conserved. Hence, the kinetic energy of the objects must be identical to the energy that is lost according to the frictional force. So the 1/2 of the m times u squared must be equal to ff times s. So now there is about 125 kinetic energies that is lost, and it is equal to 12.5 times frictional force. So the frictional force is 10 Newton. And according to the function Ff equal to mu d times Fn, so the mu d is equal to Ff divided by Fn. So it is about 10 Newton and divided by the Fn, and where the Fn is equal to the mg of the objects, which is approximately 100. So the mu d of the project is 0.1.
So that's all. If you still have any questions, please send to my email arbo.wang@studentkeystone.academy.cn. And thanks for watching.